Use Pythagorean theorem to find the missing value on each side. Pythagorean theorem says a squared plus b squared equals c squared. The most important side to identify is the c side, which is the hypotenuse. It's going to be x in number 1. It's going to be the 12 in number 2. The 6 square roots of 5 in number 3. And in number 4, it's going to be the x. The a squared and b squared, the order doesn't matter because a squared plus b squared would be the same as b squared plus a squared. 7 squared plus 4 squared is equal to x squared. 7 squared is 49. 4 squared is 16. Combining those, I get 65 is equal to x squared. And the opposite of squaring something would be finding its square root. So x is equal to the square root of 65. This would be an exact answer. It is simplified in the fact that I can't find a number that will go into 65 that I can take the square root of. I could put it in decimal form. If I put it in decimal form, x would be equal to, or approximately equal to, 8.06. Okay? Number 2, x squared plus 8 squared is equal to 12 squared. X squared plus 64 is equal to 144. Subtracting the 64 from both sides, x squared is equal to 80. The opposite of squaring something is finding its square root. So x is equal to the square root of 80. This can be simplified because it has a perfect square that will go into it. 16 goes into it 5 times. So because I can take the square root of 16 into it, this would be 4 square roots of 5. This would be my exact answer. And in decimal form, this would round to 8.94. On number 3, this looks harder because we see that we have square roots in our problem already. But algebraically, the process is really the same. A squared, x squared, plus b squared, 4 square roots of 3 squared, equals c squared, 6 square roots of 5 squared. When you're squaring a product of two things, you're squaring each individual piece. So I'm taking 4 squared times the square root of 3 squared. I'm taking 6 squared times the square root of 5 squared. 4 squared is 16. The square root of 3 squared, they're opposites of each other. They cancel each other out. So it gives me 3. 6 squared is 36. Square root of 5 squared is 5. So I have x squared plus 48 is equal to 180. If I subtract 48 from both sides, I have x squared is equal to 132. And the opposite of squaring something is finding its square root. Again, this one will simplify. 4 goes into 132 33 times. And the square root of 4 is 2. So I have 2 square roots of 33. This would be my exact form. And in decimal form, this would be 11.49 rounded to the nearest hundredth. For number 4, 11 square roots of 2 squared plus 3 square roots of 7 squared equals x squared. Again, we're squaring each individual piece. This time I'm not going to write it all the way out, but 11 squared is 121. The square root of 2 squared is 2. 3 squared is 9. The square root of 7 squared is 7. 121 squared is 242. 121 times 2 is 242. 9 times 7 is 63. And this is a total of 305. The opposite of squaring something is finding its square root. In this particular problem, the square root of 305 is simplified. And its approximate form would be 17.46. In the next three problems, we are using the concept of a 30, 60, 90 degree triangle. Remember, in a 30, 60, 90 degree triangle, that across from the 30 degree angle, we would put A. Across from the 60, I'm going to put A square roots of 3. And across from 90, I'm going to put 2A. Number 5 has a little bit of a trick in it because of this 8 square roots of 20 to start with. 8 square roots of 20 will simplify because 20 is divisible by 4 and 5, which would give me 8 times 2 radicals of 5, and 8 times 2 is 16. So where this is, I'm going to put 16 square roots of 5. Remember that across from the 30, we write equals A. Across from the 60, we write equals A square roots of 3. There's my algebraic equation. A square roots of 3 is equal to 16 square roots of 5. And the y is going to be equal to 2A. To get A by itself, I'm going to divide by the square root of 3. We cannot leave a radical in the denominator, so I multiply both the numerator and denominator by the square root of 3 to rationalize it. This gives me 16 square roots of 15, and the square root of 3 times the square root of 3 is 3. This is my A value, so x is 16 square roots of 15 over 3. Y was 2 times A, so 2 times 16 square roots of 15 over 3. So y has a value, 2 times 16 is 32 square roots of 15 over 3. That's without a doubt the hardest one that's here. Again, remember doing a 30, 60, 90. Across from the 30 goes A. Across from what would be the 60 goes A square roots of 3. Across my 30 went A. Across my 60, A roots of 3. Across from 90, 2A. If A is equal to 5 square roots of 3, any place I see an A, it can be replaced with 5 square roots of 3. So x is equal to 5 square roots of 3 times the square root of 3. When I multiply a square root by itself, it gives me back 3. 5 times 3 is 15. So x is 15. That's this side. Y is 2 times A. So where this A is, I'm going to replace it with 5 square roots of 3. And 2 times 5 is 10. So this side is 10 square roots of 3. Across from the 30 equals A. Across from the 60 equals A roots of 3. Across from the 90 equals 2A. There's my algebraic equation. 2A equals 14. I divide both sides by 2. A is 7, which means x is 7. And when I replace this A, I get y equals 7 square roots of 3. All three of these problems deal with a 45, 45, 90 degree triangle. And across from the two 45s is A. Across from 90 is A square roots of 2. So, across from the two 45s, we put equals A. That tells me what A is equal to. Across from the 90, I put A square roots of 2. Since A is 2 square roots of 3, x is also 2 square roots of 3. Y is equal to A square roots of 2, so where this A is, I'm going to replace it with 2 square roots of 3 times the square root of 2. When I multiply square roots, I multiply what's on the inside, so this is going to become 2 square roots of 6. So y is 2 square roots of 6, and x is 2 square roots of 3. Across from my 45, we put equals a. Whatever x is, y is going to be the same. And across from the 90, I put a square roots of 2. There's my equation. A square roots of 2 is equal to 15. Don't leave radicals in a denominator, so when I divide by the square root of 2 to get a by itself, I have to rationalize my denominator. So I'm going to multiply by the square root of 2 over the square root of 2, leaving me 15 square roots of 2 over 2. I could leave it this way, or if I wanted to, I could take 2 into 15 and get 7.5 square roots of 2. So x is 7.5 square roots of 2, and y is also 7.5 square roots of 2. Remember, again, across from the 45s, we're going to put equals a. Whatever x is, y is the same. And across from the 90, we're going to have a square roots of 2. A square roots of 2 is equal to 8 square roots of 10. And we can divide by the square root of 2. If you have two radicals that are being divided, so long as they're divisible evenly, you can just do the division on the inside of my radical. 10 divided by 2 is 5, so a is equal to 8 square roots of 5, which means x is 8 square roots of 5, and y is also 8 square roots of 5. In numbers 11 through 14, they are just asking me to find the ratio. They're not asking me to find these angles. They want it as a fraction and as a decimal to the nearest hundredth. Cosine of A. Cosine means adjacent over hypotenuse. Adjacent to A is 12. The hypotenuse is 13. And in decimal form, this would be 0.92. Tangent of C. Tangent means opposite over adjacent. Opposite of C is 12. Adjacent to the C is 5. And 12 over 5 would simplify to 2.4, and if I put it to the nearest hundredth, I would add that 0. Sine of A. Opposite over hypotenuse. Opposite of A is 5. The hypotenuse is 13. And 5 over 13 would become 0.38 in decimal form. Cosine of C. Cosine means adjacent over hypotenuse. And remember that adjacent to C is 5. And the hypotenuse is 13. And I can see that this came up the same, so this will also be 0.38. All of the remaining problems are based off of this. SOHCAHTOA. We're going to start at an acute angle, and we are going to determine which pieces that they've given us. Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. And it's going to give us sine, cosine, or tangent. We started an acute angle. We're going to label our parts. X is opposite. The 54 is the hypotenuse. Opposite and hypotenuse is a sine function. So the sine of the angle, 36, is equal to the opposite, x over 54. And we are going to multiply both sides by 54. This actually gets keyed into the calculator. Please don't wait till Friday to figure out how to key this in. This would key in 36 sine times 54 equals. And when I do that, this would round to 31.74 rounded to the nearest hundredth. When I go to find y is adjacent. Obviously the 54 is still my hypotenuse. Adjacent and hypotenuse is a cosine function. The cosine of 36 would be equal to the adjacent y over the hypotenuse 54. And we're going to multiply both sides by 54. This is what gets keyed into the calculator. And so we'd key in 36 cosine times 54 and hit equals. And this will come up to 43.69, rounded to the nearest hundredth. There's my x and my y. Start at an acute angle. The y is opposite. The 10 is the hypotenuse. Opposite hypotenuse, sine. The sine of 62 is equal to the opposite y over 10. And I'd multiply both sides by 10. Leaving me y being equal to 8.83. When I go to find x is adjacent. I have 10, that's the hypotenuse. Adjacent and hypotenuse would be the cosine function. The cosine of 62 would be equal to x over 10. And to get x by itself, I would multiply by 10. 10 cosines of 62 gets keyed into my calculator. And this would be 4.69. There's my x and my y. Number 17 has a unique aspect that they didn't give us one of the acute angles. So to find y, we are going to do what we did on the front side of this worksheet. We're going to do a squared plus b squared equals c squared. And remember that the y is across from the 90-degree angle. It's the hypotenuse, so it's the c side. 6 squared plus 20 squared is equal to y squared. 6 squared is 36. 20 squared is 400. So what I'm going to do is end up taking the square root of 436. When I do that, the square root of 436, y is approximately equal to 20.88. When I go to find the acute angle, I'm still going to label the parts that they've given me. I don't want to use a number that I found. I want to use numbers that they've given me so I don't have a rounding problem. 6 is opposite. The 20 is adjacent. Opposite and adjacent is a tangent function. So I'm taking the tangent of x is equal to 6 over 20. The opposite of finding the tangent of something is finding the inverse tangent. This is how I'm going to get x by itself. But if I do it on one side, I have to do it on the other. This ends up being what gets keyed into the calculator. Remember that when we're keying this one in, we're going to key in 6 divide 20 equals. Then we're going to hit that second function and then the tangent button. And if I do that, this will come up to like 16.6 something, but they said round to the nearest degree. So x is going to be 17 degrees. Number 18, if we start at this acute angle, x is opposite. 5 is the hypotenuse. Opposite and hypotenuse, sine. The sine of 7 is equal to x over 5. Multiply both sides by 5 to get x by itself. This is what gets keyed into the calculator. And x ends up being equal to 0.61. Y is adjacent. So I have adjacent and hypotenuse. That's a cosine function, cosine of 7. is equal to y over 5. And I would multiply both sides by 5. This is what gets keyed into the calculator, and y ends up being equal to 4.69. There's my x and my y. Number 19. If I start at the acute angle, x is opposite. The 18 is adjacent. Opposite and adjacent is tangent. The tangent of 25 would be equal to opposite x over 18. Getting x by itself, I'm going to multiply both sides by 18. This is what I'm going to key into my calculator. And when I do that, I get 8.39 for x. The 18 is adjacent, but the y is the hypotenuse. Adjacent and hypotenuse would be a cosine function. The cosine of 25 is equal to the adjacent 18 over the hypotenuse, which is y. We don't solve for y when it's in the denominator, so we're going to multiply both sides by y, giving me y cosines of 25 is equal to 18. And to get y by itself, it's being multiplied by the cosine of 25, so I have to divide by the cosine of 25. This is what gets keyed into the calculator, giving me y equals 19.86. And again, just talking about how this would be keyed in, this would be keyed in 18 divide 25 cosine. But remember, you have to hit equals so it'll do that division. Here they're asking me to find both angles, x and y. If I find x, the 3 is adjacent, the 15 is the hypotenuse. Adjacent and hypotenuse is a cosine function. The cosine of x would be equal to 3 over 15. The opposite of the cosine of x is the inverse cosine. This is what's going to get keyed into the calculator, giving me x is equal to, and if I take the inverse cosine of 3 divided by 15, I get x is equal to 78 degrees. I could use sine, cosine, or tangent to find y. Y and the 3, this would be opposite. The 15 would be the hypotenuse. Opposite and hypotenuse would be a sine function. So the sine of y would be equal to 3 over 15. And again, to get y by itself, I would do an inverse sine. That's what's what get keyed into the calculator. This will come up to 12 degrees. Once I had one of these angles, though, I know there's 180 degrees in any triangle. So I could have said 90 plus 78 was 168 degrees. And I could have taken 180 minus the 68, the 168, and found out that it was going to be 12 degrees like we came up with here. When you're doing the word problems, you are going to draw a right triangle. It's going to pay you to label your parts. A 22-foot flagpole. This is obviously the pole. This is obviously where the ground is, or the shadow would be. A 22-foot pole. This is 22 feet. Casts a shadow 62 feet long. So this is 62 feet. Find the angle of elevation. This is where the angle of elevation is, and that's what they're asking me to find. We start at the angle, we label our parts. This is opposite. This is adjacent. Opposite and adjacent is the tangent function. The tangent of x is equal to the opposite 22 over 62. The opposite of finding the tangent of something is finding its inverse. So we write tangent -1. Would cancel these out, leaving me x is equal to, and this gets keyed into my calculator, and we should find out that this is 19.5 degrees, which rounds up to 20. Again, still having difficulties of where to put things in. Keep in mind that they're talking about a tower. Obviously, my tower is upright. They're talking about the ground. Obviously, my ground is down here. And they're talking about a cable that's fastening the tower to the ground. That's this slanted piece. They said the tower is 80 feet. They said the cable was 215 feet. And they want to know the measure of the angle formed between the wire and the ground. In other words, this angle of elevation. 80 is opposite, the 215 is the hypotenuse. Opposite and hypotenuse is a sine function, so the sine of x is equal to 80 over 215. To get x by itself, we use its inverse. This is what we're going to key into our calculator, and we should find out that x is 22 degrees. In other words, the cable is making a 22 degree angle with the ground. A child holds the end of a kite string on the ground. Obviously, this is the ground. Obviously, my kite's up here somewhere. And if my kite is up here, this must be my string. It says the string is taut. In other words, the string is pulled tight, and it makes a 68 degree angle with the ground. This is 68 degrees. How high off the ground, this is the distance it is from the ground, this is x, if the kite string is 120 feet, this is 120. We started our angle, this is opposite, this is the hypotenuse. Opposite and hypotenuse is a sine function, so we're taking the sine of 68 is equal to the opposite over the hypotenuse, x over 120. We'd multiply both sides by 120. This is what I'm going to key into the calculator. And I find out that the kite is 111.26 feet off the ground. An airplane takes off at an angle of elevation of 56 degrees. This is 56 degrees. This is obviously the ground and the horizontal distance. This is the vertical height or the vertical distance, the altitude. This is 56 degrees. What is the ground distance? The ground distance would be down here. If the altitude is 3,000 feet, this is 3,000 feet. It's 3,000 feet in the air. They want to know how far it would have traveled if it had stayed on the ground. Opposite, adjacent. Opposite and adjacent is a tangent function. Tangent of 56 is equal to 3,000 over x. And to solve, we would multiply both sides by x, giving me x tangents of 56 is equal to 3,000. And then we would divide both sides by the tangent of 56. So x is equal to, we key this in the calculator, and this comes up to 2,023.53, and this would be feet. Make sure you know how to key things in the calculator. You should be able to do sine, cosine, and tangent, angles of elevation, angle of depression. You should be able to do Pythagorean theorem and the two special right triangles, as well as being able to simplify a radical if need be. Take your time. Make sure that you study. We'll have another review tomorrow.